lesson, you're going to learn about something called combination of functions. The combinations that we'll look at are sums, differences, products, or quotients, or combinations of those, applied to different functions. First of all, some notational things to know about in this box. Sum of functions can be written as a function f plus g in brackets that are functions of x. That's why the x is there. And what that's saying is take the function f, add the function g. Those are equivalent notational forms. Similarly, if I want to take a difference of functions, I can write f minus g, functions of x, or I can write f of x, subtract g of x. For products, there's a similar notation, and for quotients, again, a similar notation. The things on the right should be familiar to you and make sense. The items on the left might be new, but they're equivalent to what we see at the right. So we're going to work a number of examples now. The first part, in example 1 here, I've defined some functions f, g, and h for you, and I would like to find f plus g of x, then f times g of x. So you could pause the video right now and try to answer this question, then come back once you've got answers and check your work. All right, hopefully you've done that and you've got some answers to compare to what I'm about to write. When I write f plus g of x, just like it says above, it's f of x and g of x. F of x is 2x minus 3, g of x is x and 1, so combined I have 3x minus 2. That's the result for A. For B, this is f of x multiplied by g of x, so I am going to write 2x minus 3 with a bracket representing f of x, and I'm going to write x plus 1 representing g in another bracket, brackets being very important to give the idea of multiplication of the complete function by the other function. This is a binomial times binomial. There's a certain pattern for that you might recall called FOIL, first, outer, inner, and last. It's going to produce 2x squared plus 2x minus 3x, so minus x minus 3, your answer for the product. Using the same two functions, now try these. H divided by g with an input of 3 is what this is saying. And lastly, f times g with an input of 1, subtract f times h with an input of negative 1. Again, pause the video, try them out, see what you come up with, and compare your work to what I have. Hopefully you tried that out, and you have something to compare to. What is asked is equivalent to this. It means take the function h, substitute 3 as the input, take the function g, substitute 3 as the input. This is going to lead to 9 over 4. A numerical input for a domain is going to give a numerical output for the range. Next one, I'm going to take advantage of the fact that I already know what f times g is from part B, and I'm going to substitute 1 into this answer. So I'm going to have 2 times 1 squared, subtract 1, subtract 3. That's the first part. Now I'm going to subtract all of this. I'm going to use a bracket, and I want f times h. This is f with a substitution of negative 1. And we put it in a bracket because all of f gets multiplied by h. Here's h, x squared with a negative 1 substituted. This is f, this is h, the substitution of negative 1. Let's simplify. This is 2, subtract 1, subtract 3, so that's negative 2. This is negative 2, subtract 3, or negative 5. Negative 1 squared is 1. This bracket becomes negative 5 being subtracted, so add 5 to negative 2. Final result, positive 3. So that's how to work with functions that are defined and combining them together with adding, subtracting, and possibly substituting numbers. Now the other thing you're going to have to be able to do is work with graphs, such as these ones. Again, I've defined some functions f, g, and h. This time they're each functions that you don't get an equation for, but you have a visualization of them. So you know a whole bunch of domain values and corresponding range values. And what we're going to want to do with these is evaluate these three questions here. Again, pause the video, try it out, and then come back and rejoin me and see how you did. All right, let's see how you did on this one. This is the function f and the function g evaluated at 2. Well, the function f evaluated at 2 has the result of 1. The function g evaluated at 2 has the result of 5. So this is 1 plus 5. 6 is your answer. I evaluate each function separately for the number 2 to get the result and add those up. Next, I'm evaluating the function f, g, and h multiplied together for the input of 0. F with an input of 0 has a result of 2. I'll multiply that. G with an input of 0 has a result of 3. And h with the result of 0 has a result of 2. This answers 12. This next one's a little bit tricky. Notice I don't have an input number. I'm saying for all x values, multiply the function f by the function g. Well, we don't have equations to work from, only these images, these graphs. Two ways we could go about doing this. I would suggest that you do this method that I'm about to show you. The second method that I'll talk about afterwards is a sort of a shortcut once you get more skilled at it. So I'm going to make a table of values. And you'll notice the function f, I can choose any values of x domain that I want. If I look over at the function f, it's well defined for even numbers. 0 is well defined, -2 is well defined, -4, -6, and so on. So I'm going to choose to work with those numbers. -4, -6, -2, write them in order. 0, 2, 4, that's probably sufficient. If I look at g, g is well defined for all integer values, so we should be fine. Now, this says take the function f for each x value, so that's a y value, and multiply it by the same result from g. So the function f evaluated at -6, well, that's 1. The function g evaluated at -6 is 5. So when the domain value is -6, the product of the functions give the result of 5. I could graph that. -6, 5. Let's try -4. This is 0. This is 3. The result, 0. So -4, 0. At -2, I have 1 times 1, the result, 1. At 0, function f is 2, function g is 3. 2 times 3, or 6. At 2, 1 and 5. 1 times 5, 5. That's when I'm at 2. And at 4, 0, and looks like 7 perhaps. I kind of worked it quickly. It doesn't really matter because the answer is 0 anyway. So I have a strange assortment of dots that I need to configure here. Just try to make a sort of a smooth curve through it. Maybe I'll choose one more point. Let me try 6 as well. That's 1, and this looks like it would be up here somewhere at 6, 7, 8, 9 by the look of it. So at 6, 1, 2, 3, 4, 5, 6, 7, 8. I'm just slightly off the graph here. Now, the product of lines that change with different slopes aren't going to produce linear results here. These are going to be a little bit curved. Okay, so I'm going to have something kind of like that. This is going to have a quick change upward, and it's going to have a quick change sort of downward, and this is going to go like that. I'm not terribly concerned about the curvature, but that you plot the dots correctly and that you roughly have the shape. Well, that's the basic idea of how to combine functions together by addition, subtraction, multiplying, or dividing. Good luck with the assignment.